Now let's see another dynamic routing protocol, that is link state routing protocol. Till 1980s, bandwidth was very limited. So people were sending only distance vectors, which means limited information because bandwidth was very less. What happened is after 1990, bandwidth got improved. And because of the technology, it got improved. And now we have the freedom to send more information, not that not just that very little distance vector. So we can send many other things also, so we can do something better due to the rise in the bandwidth. So LSR has become more popular in current situation, and right now as such both are used, but LSR is somewhat superior compared to the distance vector routing protocol. So in the link state routing, this is the example. Let's say we'll take it forward. So the same example, A, B, C, D routers are there, and 1, 2, 3, 11, and 7 at the different weights which are there. So these are all link state packets, and the first round is every node will find out who are their neighbors and what are the links and what are the distances, right? So how by using how it could be done is by using something called as hello packets, right? So before starting, you will just say hi, and neighbor will also say hi, and that is how you find it out. So you will find out who are your neighbors and what is the distance, right? What are the distances? So in the next step, unlike DVR, what will happen is every node is supposed to flood the information to every other node, right? So why are we flooding is we are in the process of creating routing table, and we don't have routing tables yet as such, right? Therefore, at the initial phase, what we'll do is we should use flooding, and later also anyway we are going to use flooding only. So this is as such an efficient method to ensure that data is received reliably and data is sent fast, right? So we are not using flooding for data packets, understand? For data packets, we are not going to do flooding. Only for the link state packets, only the flooding would be applied. Otherwise, no, it is going to be costly, and it is going to increase upon the traffic. So only for this link state packets, we are using this flooding. Right. So in this way, this link state packets would be flooded. Therefore, all nodes will have data from other nodes. So this LSR algorithm, is based on the global knowledge. So previous DVR algorithm, as we have seen earlier, was based on the local knowledge. So local knowledge means you will get only what your neighbor says, right? Whereas in this case, what is going to happen is, let's say at A will get the link state. What will happen is A will get the link state from all the nodes, and what will happen is what will A understand in that case would be that it will be coming to know the entire the graph, entire node structure, everything would be there with A. So what A do is it will start applying single source shortest path algorithm, which is Dijkstra's algorithm, right? So the Dijkstra's algorithm will be applied at A using this global database, and A will find out what is the shortest path from A to every other node. Therefore, A will construct its local routing table just by using the global data, right? So look at the table and using that, you'll come to know what will be this routing table at A. So A to A is 0, A to B is with distance 2, and next stop is B. So A to C is through A to B and B to C, that is 5, and next stop is B, right? And to D, it is A to D is by distance 1, and the next stop is B. So using the Dijkstra's algorithm, we can find out the routing table directly and then compare it. I mean, this would be the situation available with all the routers. So convergence is faster as such compared to DVR, and there are a few problems anyway which are there with this LSR, and to let us see those problems first of all. So since we are doing flooding, it will lead to heavy traffic, right? And it is one of the problem of LSRs, right? So let's say there are routers arranged in this situation, and what will happen is the packets are sent by through multiple routes and will be reaching to one of the router, let's say the bottommost router, right? So A is sending with some number. So there is a concept of sequence number which is coming up, and with some sequence numbers, send with the every packet. I mean, whenever there is a broadcast sort of thing. So what will happen is the receiver, the neighboring nodes will come to know that what is the sequence number for that. And this is like, let's say A is broadcasting one packet with the sequence number 10, and there was an old packet which was there with the sequence number 5. So by that, the sequence number will come through the sequence number. The routers, neighboring routers will come to know that this is the latest packet, and the other one is the old packet. So this is going to not only happen to only one router, but this is going to happen at all the routers. So at every router, it will have to maintain information related to the sequence number for every router, right? So what will happen at A is, let's say, it is supposed to have the information at the router with sequence numbers, right? So router A itself does not require any sequence number. I mean, it has to maintain the information for B, C, and D, right? So B is having latest sequence number of 10, then 20. For C and D is having something like 30. So this is one such arrangement. Let's say it's there. And now let's say if B8 is coming up, then what will happen is, because the sequence number itself is 10, so what will happen is it will be discarded, right, as it was old. Now let's say B15 is coming up. So what will happen is it will be accepted and take the information from this latest packet and update your, what it will do is it will update your global table, and now it will be changed from 10 to 15. That's why I know that 10 is replaced to 15. Now let's say if B11 is coming up for some reason, and then so what will happen is it will be discarded. And also, whenever you know that the packet is latest, that packet has to be flooded, right? So we are going to flood only the latest information and never the old information. Therefore, flooding somehow is decreased, because we are just communicating the new information and not the old information, right? So let's say A to B, A to D, then C is going to receive the packet in that case from B as well as from D. So C will get 2 copies of A. And what it will do is, whenever it gets a packet for the first time, it will flood it in all the directions. But whenever it gets the packet for the second time, it will discard it. So, right. So in this way, things are going to be managed at the routers with the LST algorithm. However, what it means, I mean, it means that it has already seen it, and therefore flooding can be controlled by the sequence numbers, right? And there is still one more problem which is there, and that problem is basically of falling in the infinite loop because of some other situation. Maybe there could be a possibility, and because of that there is a infinite loop problem which could be there. So to solve the infinite loop problem, we will be using TTL. So TTL is basically time to live. Right, let's say B15, B with 15 sequence number was sent. So the binary of that was, let's say 0001111, and because of some reason, the fifth bit, from the LSB side got corrupted, and it got converted from 0 to 1. So resulting into what? Resulting into it became, instead of 15, it became 31. Right, last 5 bits are 1. So due to 1 bit of error, however, this is going undetected. And even though there is CRC, which is unreliable, anyway, we know that CRC is unreliable. So what is going to happen is, now let's say B15 was the information which was sent with sequence number 15, but then in between, on the way, it got corrupted to 31. So resulting into what? Resulting into a situation wherein this 31 becomes the latest information, and it has been broadcasted to everyone. Right, and now it is waiting for something greater number compared to 31. So it is waiting only for B32, and resulting into what? Resulting into B16 to B31, which will be discarded. So in fact, on the way there is some bit of error, and resulting into some problem inside the during the transmission. Right, so routing table will be incorrect for some time. So to solve this problem, rejecting many valid packets, until you get something proper. We associate with every packet validity or the lifetime of the packet. So it's nothing like it's nothing but the time duration is implemented, and for some time for some fixed duration, we will use this entry. Even though the packet is latest, but after the validity period is over, it will be discarded. And then at that time, whenever whatever is the latest packet, you will have to take it. Let's say example B33 will be accepted, right? And this duration is implementation dependent, and it could be anything and any number that depends upon the agreed upon situation. It may be 15 also, it may be 30 also, 30 minutes also. So problem in this situation, we have seen that there could be some problems which are intrinsic problems, and these are the problems intrinsic to the algorithm. And for some time, we can say that it is basically divided into two sort of things. One is a transient problem, that is for some time that the problem exists and will automatically correct themselves from that situation after some time. So those type of problems are known as transient problems. And for some time, there could be a problem of looping, and after some time that looping is automatically recovered from that, and it will become a normal one. So that type of problem could be transient problem. Next is the persistent problem. Persistent problem is like it is forever, and it was we have seen that it was there inside the DVR sort of algorithm, right? So in the transient, the problem remains basically for temporary time duration, and and in the, let's say, the example of looping, and there is a concept of black hole also, which is that black hole is something like A to B link is there, and that B link is broken, but by that time that B will recognize that A has that link between A and B is broken. A lot of data has been sent by A, and God knows what will happen for this transmission which has been done. Normally what will be done is it will be on the way, it will be discarded, right, and will not receive to the receiver, right? So that is the basic. It will be there for some time, it will not be forever, right? So next is the situation where the looping problem could be there. So A will come to know about the problem with B, right? In this case, A will come to know about problem with B, but C will not come to know immediately. So for some duration, it will still try to send a packet to A, right? And to send it to B, right? So it was as it was the shortest path. What I said is that C will not come to know immediately. So for some duration, it will still try to send a packet to A to send it to B, as it was the shortest path. So the path was A to C. There could be possibility of A to C, C to A to C, and so on. So looping, there is a possibility of looping, and which could be there until C discovers that the new shortest path is C to D to B, right? So C to D to B, not the other way, right? So it is a transient problem, and they will correct themselves. So it is not a problem for LSR for a long time, understand? So LSR is having a looping problem, which is a transient and not the persistent. So in case of DVR, we have seen that looping is persistent, and the solution for that was split horizon. Right. So we have seen the algorithms, or the link state routing algorithm, and we have seen the distance vector routing algorithm. Let's see what are the differences between these two dynamic algorithms. So DVR, you may note down while I'm speaking out all this information. It will be really useful to you, and it is useful to know all this information. So DVR and LSR. So DVR is it was developed somewhere in 1980s, and LSR it was majority of the time it was used in 1990s and onwards. Once the LSR came into existence, DVR is very rarely used. So bandwidth required is less in DVR, and bandwidth required is high in LSR. And DVR basically works on the local knowledge, well as LSR works with the global knowledge. And DVR, there was a Bellman-Ford algorithm which was there, and LSR, it makes use of the Dijkstra's algorithm. So traffic is less in DVR, traffic is very high in LSR, and periodic updates are required in both DVR as well as LSR. Also in terms of convergence, convergence is done slowly in DVR, and convergence is faster in LSR. Then we have seen the count to infinity problem was there in the DVR, and there was no count to infinity problem in LSR, right? And persistent loops were there. It was like most of the time loops were there, and transient looping was there in the LSR, right? So the algorithm, the application which was making use of this, or the protocol which was making use of DVR implementation is RIP. RIP is an implementation of DVR algorithm, whereas OSPF, Open Shortest Path First, is an implementation of LSR algorithm, or it is the concept of that, right? Computation is very simple in DVR, and as far as the computation of LSR is concerned, it is complex as it has to update global databases, right? So RIP to DVR, no, there is a metric. Metrics is the hop count which is there. So using that hop count, no, the infinity, if it is 16 in RIP, no, there is some value which will say that, okay, this is the infinite value in the routing protocol, RIP protocol, which is an application of implementation of DVR algorithm. As far as OSPF is concerned, there is a flooding which is restricted to zone, keeping traffic very, very less, and the border routers, will be sending the data to the area, or the area 0 or zone 0 or backbone router, and through that, it will get connected to the other side network. So summary, from region is going to be forwarded by border router to area 0 or to the backbone 0, and hop count is not used in this LSR. Network administrator will put the weights on the links. So this is all about the LSR algorithm and the difference between the DVR and LSR. I request students to undergo this video a couple of times to understand the concepts more clearly. Thank you very much for patience listening.